In this video, we're going to focus on two different ways of finding instantaneous velocity. So I've given a position function here, s of t equals 1 over t plus 1, and a point I'm interested in, t equals 3. So I've started the definition here. What I'm interested in is the limit as h goes to 0 of s of 3 plus h. I'm interested in focusing at 3. Here's my plus h, moves me a little bit forward in time. This top expression tells me my change in distance. That's my change in time. Let's take one more step by actually plugging these values into our s function. So if I plug 3 plus h into this function, I get 1 over 4 plus h, minus if I plug in 3, I get 1/4, and that's all over h. Now, let's talk about how we're going to find this. The first way we're going to do this is we're going to do this numerically, which means that what we want to do is we want to make a table of h values that are heading towards 0, and we will talk about our estimates for the derivative. So let me just make sure that we're okay with this. I'm going to try, for example, first 0.1. Now I'm going to put the number in there, but I want to show you how I got that. That's going to be 1 over 4 plus 0.1 minus 1/4 all over 0.1. You can set up your calculator in a table to do this, or you can just do a lot of calculations. But let's see, to 5 decimal places, I got negative 0.06098. Now, what we want to do is we want to keep on doing this. So for 0.01, I got negative 0.06234. And for 0.001, I got negative 0.06248. Now, I should be careful. I want the limit as h approaches 0, not just from positive values. So I should check some negative values as well. Negative 0.01 gives me negative 0.06266. And negative 0.001 gives us negative 0.06252. Alright, we can definitely get more values. Now, I want to check. If you're having some issues finding these values, if you can't match what I'm getting here, that is a great thing to bring up in class or talk to me in my office hours about, because I want to make sure that you're getting these numbers doing a calculation like this. Now we want to emphasize what's showing up. Notice that we always have the minus sign. We appear to be matching that 0.6 in all of the calculations. And you notice that when we get very small, we feel very confident that the next two are a 2.4. Round that up, that would be a 2.5, and that would be a 2.5. Alright, so in other words, we've got a guess. So our estimate is going to be, we're approximately equal to negative 0.0625. That's our guess for the instantaneous velocity of this function at that point numerically. Now, we've done that numerically. Let's do that algebraically. So, when we're doing this algebraically, what we want to be doing is working with this limit. Notice that for right now, I cannot take this limit and plug in h equals 0, because then I would have a 0 on the denominator. So instead, we're going to take that limit and perform some algebra. In particular, I'm going to get a common denominator and add these two fractions up here. So the first fraction is going to be 4 over 4 times 4 plus h minus 4 plus h over 4 times 4 plus h, the whole thing over h. Note that I still can't plug in h equals 0. I got an h down there. Well, let's simplify that a little bit. Notice that I'm subtracting up here. You might want to think about the fact that that 4 plus h can be thought of as being in parentheses, and that minus sign is going to be distributed there. So if I want to think about what's going on here, I can think of this as a plus, and there's a minus sign here, and there's a minus sign there. And in that case, the 4's will cancel, and I will have a negative h on the top. Negative h over 4 times 4 plus h. Now I'm dividing by h, and instead of dividing by h, I'm going to write that as multiplying by 1 over h. Because when I do that, now another great thing happens. My h's cancel out. And now what I have is the limit, as h goes to 0, of negative 1 on top and 4 times 4 plus h on the bottom. This is good, because now when I plug in h equals 0, I don't get 0 on the bottom. I actually get a value. In fact, when I plug in h equals 0, what I get is negative 1/16. That's algebraically how to find the instantaneous velocity. And heck, look at this, in decimal form, that is exactly the guess that we got earlier. That is negative 0.0625. In class, we will talk about how to do this graphically as well, so there's one more way to do this. But the purpose of this video is to help you understand how we can find an instantaneous velocity in two different ways. We did it numerically, we did it algebraically.